So hello everyone, you can see this first question. An AC voltage source of variable angular frequency omega and fixed amplitude V naught connected in series with capacitance C and an electric bulb of resistance R, inductance 0 when omega is increased. Okay, so basically this is RC circuit, correct? So you draw one is R, one is C, correct? Connected to a AC source, RC circuit. Okay, angular frequency omega. Okay, so I can write V equal to V naught sine of omega t. This is voltage source. So what is the current in the circuit? Current in the circuit will be V naught by Z. So I can write V naught by Z is root of R square plus XC square. So basically V naught by root of R square plus 1 by omega is 2 pi f c whole square. So if I increase, okay, they are asking in terms of omega, so I can directly write omega c square. Okay, 1 by omega c xc. So if I increase omega, then this denominator will decrease, then current will increase. So if current is increasing, the bulb will glow brighter. So option is 2. Second question. You are given many resistors, capacitors and inductors. These are connected to a variable DC voltage source. The first two circuit or an AC voltage source of 50 Hz frequency, the next three circuit in different ways as shown in column 2. When current I steady state for DC and RMS for AC flows through the circuit, corresponding voltage V1 and V2 indicated in the circuit are related as shown. Match the column. Okay, so you can see they have given two column, some circuits they have given. So first one is DC circuit, correct? This is DC but voltage is variable. Okay, so if it is DC current, they told steady state. Okay, so at steady state, inductor acts as where, simple where, correct? So if I consider this acts as simple where, so definitely V1 will be 0. So all the potential will drop across the capacitor. So V2 will be V. So here V1 is 0, V2 equal to V. First point. Okay. Steady state. What is the current in this steady state at t equal to infinity? At t equal to infinity, capacitor acts as close or open circuit. Okay, so if it acts as open circuit, I will be 0. So I am getting V1 0, V2 will be V, V2 will be V, V1 0, V2 V, and I is equal to 0. First one. Okay, second one. Again here current at steady state will be V by 2 because inductor acts as where. This will act as where. So here also V1 equal to 0 and V2 will be equal to V. And current in the circuit is V by R, that is V by 2. Okay. Third circuit. Let us try to analyze this third circuit. So this is AC source. So for AC source, let us try to calculate what is the current in the circuit. So current in the circuit, definitely it is not 0. So current in the circuit will be what? Current in the circuit will be V by Z. Okay, Z will be root of R square plus XL square, that will be Z. So current is not 0. What is V1 and what is V2 I have to find. So for V1 and V2, let us try to calculate XL and R. R is given 2 ohm anyway. So XL is omega L. What is omega? 2 pi. Frequency of circuit is 50 Hz. So 2 pi 50 into L. L is given 6 into 10 to the power minus 3. Okay. So solving this, 2 pi into 6. 2 into 50 is 100. 6 into 3, 18. So you get approximately 1.8 into 10 to the power minus 3, and this side will, yeah, 1.8. You get approximately 1.8 ohm. And what is R? R is 2 ohm. So definitely here I can say that V1 is directly proportional to current voltage across inductor, because what is V1? V1 is I into XL. Okay. And V2 is I into R. Correct. And I know R is greater than XL, so I can also write that V2 is greater than V1. Okay. So I am analyzing the circuits first, then I will match with the option. So in the fourth one, again this is AC source. Instead of resistance, here is the capacitance. Okay. So current in this circuit, definitely current is not 0. So what will be the current? Current will be again V by Z. Okay. So that will be V by root of XL square, XL minus XC whole square. V by root of XL minus XC whole square. So basically V by XL minus XC directly you get. Okay. R is 0 here. So current is not equal to 0. First of all, let us try to calculate XC. XC is 1 by omega C. Okay. So 1 by 2 pi, frequency was 50. C is 3 into 10 to the power minus 6. If you solve this, you get 10 to the power 6 above. 50 into 200 into 3, 100 you take 100 and 3 pi. Okay, 3 pi, correct. So approximately here you are getting the value is 10 by 3 pi into 10 to the power 3. Okay, 10 by 3 pi into 10 to the power 3, that is equal to 1.06 into 10 to. Okay, so this is the value of XC you got, and XL you know from the previous problem. XL will be equal to, XL will be 1.8 ohm approximately. So here obviously XC is greater than XL. So that means V2 is greater than V1. Okay. V1 will be what? I into XL. V2 will be what? I into XC. Okay. So definitely V2 is greater. Correct? Okay. Now last diagram. Okay. So for the last diagram, they have given that capacitor and resistance, RC circuit, AC source. So you know the value of XC is 1.6 into 10 to the power 3, and value of R is 1 into 10 to the power 3. So here XC is greater than R. If XC is greater than R, I can say that VC will be greater than VR. Okay, so basically V2 greater than V1, V2 greater than V1. Okay, because Vc will be I naught into Xc and Vr will be I naught into Vr will be I naught or I into, you can write I into R. Vc will be I into XR, Xc, sorry. So Xc is greater than R, so V2 is greater. Current in this circuit, again current in this circuit is not equal to 0. Okay. Now I have analyzed all the circuits. Now try to match this. So first one, I not equal to 0. So I not equal to 0, you see, I not equal to 0, I not equal to 0, here also I not equal to 0. So RST, RST I can write RST, and V1 is proportional to I. Yes, everywhere V is proportional to I, because net V1, yeah, V1 voltage in inductor and this resistance. So everywhere V equal to I into XL, in this case, first case I into XL. Here also V will be I into XL. Here V is I into R. So V is directly proportional to V1. V1 is directly proportional to I. That's true. So first one done. Second one, I not equal to 0. I not equal to 0, you can see RST. So for B, RST, and even for Q also, QRST, V2 is always greater than V1. Yeah, so in this case for Q also, V2 is V, V1 is 0, so V2 is greater than V1. Here also V2 is greater than V1. For S also V2 greater than V1. Yeah, so QRST, correct. For C, V1 is 0, V2 equal to V. V1 is 0, V2 equal to V. I got, I think, P. Okay, this answer is P. And Q also. Okay, so here answer is given wrong in your module. So answer will be P and Q. P and Q. Okay, you can see here P, V1 0, V2 V. Even for Q also V1 0, V2 V, because Q also inductor acts as simple wire, no potential drop at steady state. So P and Q. Option D, I not equal to 0. So I not equal to 0, QRST 4. V2 is proportional to I. Definitely V2 everywhere is proportional to I. V equal to IR. Okay, I into first one V equal to IR. Second one V equal to IR. Third one V equal to I into XC. Fourth one V2 also I into XC. So here also it will be QRST. Okay. So I hope you understood this problem. Let us proceed to next problem. This transformer I will not do now. This is easy. Fifth one will do. So at t equal to 0, terminal A in the circuit shown in the figure is connected to B by a key, and an alternating current IT equal to I naught cos omega t with I naught equal to 1 ampere and omega equal to 500 starts flowing in it with initial direction shown in the figure. Okay, so initial direction of current is this. At t equal to 7 pi by 6 omega, the key is switched from B to D. B to D, key is switched. Now onwards only A and D are connected. Now A and D are connected. Basically this is capacitor connected with a battery. A total charge Q flows from the battery to charge the capacitor fully. Okay, capacitor they have given, C is 20 microfarad, R is 10 ohm, and the battery is ideal with EMF 50 volt. Identify the correct statements. So for this question, let us try to find how the charge is, how the capacitor is getting charged initially, because initially it's connected to some AC source, correct? So I can write here I equal to I naught cos of omega t, which is given, and I is equal to dq by dt. So dq equal to I naught cos of omega t dt. Integrate it from where to where? 0 to 7 pi by 6 omega, because capacitor is getting charged only till this time. After that it is disconnected and connected to D. So 0 to 7 pi by 6 omega. Okay, so if I solve this, I get q equal to I naught is 1, integration of cos omega t is sin omega t by omega, where to where? 0 to 7 pi by 6 omega. So if I solve this, what I am getting? 1 by omega is 500. So q equal to 1 by 500 sin omega t. Sin of omega is 7 pi by 6 omega into omega t, t 7 pi by 6 omega into omega. So 7 pi by 6 minus sin 0. Anyway, sin 0 is 0. Okay. So q equal to sin 7 pi by 6 is sin pi plus pi by 6, correct? So sin 180 plus pi by 6, so minus sin pi by 6. So I get minus sin pi by 6 is half, minus 1 by 500 into 1 by 2. Na? So I am getting q equal to minus 1 by 1000. That means minus 10 to the power minus 3. Okay. So this is the initial charge in the capacitor. Okay. So charge in the capacitor is negative. So basically I can write here, this part is negative and down part is positive for the capacitor. Okay, note it. Okay. Now what I did, I shifted the switch from B to D. So as soon as I shift the switch, finally this battery, from this battery capacitor will get charged. Now what is the final charge at steady state? At steady state, charge in capacitor will be, because resistor overtact, q equal to cv, 20 into 10 to the power minus 6 into v is 50. So 1020 into 50 into 10 to the power minus 6. So I get 10 to the power plus 3. 10 to the power, no, 10 to the power minus 3 plus of 10 to the power minus 3. So now you can see that initially charge was minus of 10 to the power minus 3 and finally charge is plus of 10 to the power minus 3. So how much charge flown from the battery? Q flown will be 2 into 10 to the power minus 3. You can see option D. So option D is definitely correct. Okay. We'll see about other option also. The current, okay. Magnitude of maximum charge on capacitor before t equal to 7 pi by 6 omega is 1 into 10 to the power minus 3. So I think this is wrong, because I got q as a function of time. What is q? Let us do q. Q is 1 by omega sin of omega t. Okay. What is the maximum value of sin omega t? 1. So 1 by 500. 1 by 500 is the maximum charge. This is q max. So first one is definitely wrong. Okay. Current in the left part of the circuit just before t equal to 7 pi by 6 omega is clockwise. Okay. What is the current? Current initially it was clockwise, and the graph of current is I naught cos omega t. So graph will start from here, go like this, correct? So this is pi, correct? 7 pi by 6 omega pi plus pi by 6 है ना. So this is 7 pi by 6 omega, this pi plus pi by 6. So at this time you can see current is negative. So current is negative means what? Current is flowing in this direction, I. So this is anti-clockwise, anti-clockwise. So second option is also wrong. Okay. Third option. So for third option, I'll just clear this place. I'll do here at the corner. So for third option, what that means? Immediately after A is connected to D, the current in R is 10 ampere. So if A is connected to D, let us try to write the equation. KVL, I'll write KVL from here. Okay. Plus 50, and here immediately after, no, so immediately it was minus only, minus of Q by C. Okay. Okay, this side was minus, this side was plus, so I am going from negative to positive in the capacitor, so increase in potential, so I'll write plus Q by C. Okay, and value of Q, I'll just take the magnitude. Plus 50 plus Q by C minus IR equal to 0. Plus 50 plus Q is how much? Value of Q is 10 to the power 3. 10 to the power minus 3. Divided by C is how much? C they have given 20. 20 into 10 to the power minus 6. So I'll write 10 into 10 to the power 6 equal to I into R. So 50 plus 10 to the power plus 3, 100 by 2, 50. 50 plus 50, I is 10 into R. So from here you get R equal to 10. That's correct. Not R, sorry, I. Here they have given R is equal to 10. They are asking I. So I also you get 10 ampere. Okay. So option C is also correct. Okay. Okay. Next, let us proceed to question number 6. So question number 6, what they are saying? In the circuit shown, L equal to 1 mH, C equal to 1 mF. So here this question is little wrong. Make it micro. Make it micro. Okay. In the diagram they have given correct. Okay. R equal to 1 kilowatt. They are connected in series with an AC source V equal to V naught sin omega t. Which of the following options are correct? Okay. So what is they are giving angular frequency at which current will be in phase. So first option, angular frequency for at which current will be in phase with voltage is independent of R. So when current is in phase with voltage, that means this is the condition for resonance. Correct. At resonance phi is equal to 0. Phi equal to 0. So current is in same phase with the voltage. So if phi is 0, I can write omega equal to 1 by root of LC. I think you know this. Okay. XL equal to XC for resonance. So definitely omega is independent of R. So A is correct. B. At omega 0, the current flowing through the circuit becomes nearly 0. So if omega is 0, voltage will be 0, correct? Because V equal to V naught sin omega, if voltage is 0, no current will flow through the circuit. So B is also correct. Let us try to see option C. If omega is greater than 10 to the power 6, so I'll find omega. What is omega? Omega is 1 by root of L. See, L is 1 into 10 to the power minus 6. C is 1 into 10 to the power minus 6. So omega I am getting 10 to the power 6. So this is resonant frequency. So if omega is greater than 10 to the power 6, you know that if frequency is more than resonant frequency, circuit acts as inductive. So here they have given capacitor behaves like this is wrong. Correct answer is it acts as inductive or inductor basically. This is wrong. So you remember omega less than omega resonance, it acts as capacitive. Omega greater than omega, it acts as inductive. Option D. The current will be in phase with voltage if omega equal to 10 to the power 4 radian. No, this is wrong. The answer is if omega equal to 10 to the power 6, then it will be in phase, that is